Hi everyone, my name is Brittany Reese.
I'm Augustine Hart.
I'm Hunter Lyons.
I'm Jonathan Hughes.
And I'm Vincent Toledo, and this is our solar design presentation for Boalsburg Fire Co.
To start us off, I'll go over a short overview to discuss all we'll be covering today. We'll begin with some background on the Boalsburg Fire Company, followed by the goals and significance of our project. We will then dive into the initial development plan and the solar array designs we completed as the project progressed. A financial analysis on the designs was completed, which then led us to our final recommendation. And then finally, to finish up the presentation, we'll talk about the impact the solar implementation could potentially have on the community. So starting off with some background on the Boalsburg Fire Company, it's located in Center County, PA. It was unofficially organized in the late 1800s and has completed 134 years of service. The fire company is community focused and volunteer driven, so it relies on fundraising and municipal support. It serves Harris Township and is responsible for over 400 plus residential homes, so it's clearly an important asset to the community. And overall, this establishment provides fire suppression, emergency responses, and public safety services.
So our local client was looking for two things. One is is a source of affordable energy in the face of rising costs from the current electrical grid, and the second is a reliable source of energy as well. I think we all remember the blackout last year. I know although the Boalsburg Fire Company was definitely able to manage with a backup generator, they're still looking to be able to transition away from that and be able to have a continuous stream of energy. So therefore, our objective for this project was to design and recommend a solar panel system for the Boalsburg Fire Company. So we had lots of things to consider when making this project. The first is regulation from local administrations, such as the Harris Township and the Center County, namely the Center Region Code and Administration. We'd also have to make sure that all infrastructure and designs were approved by the local electrical utility, namely West Penn Power. And then we had to comply with codes that range from statewide codes to international codes, such as the PA Uniform Construction Code, the National Electric Code, the International Fire Code, and the Building Construction and Safety Code. So to offer an initial development plan for our local client, the first thing we would have to do is obtain approvals from both Harris Township and Center County. Then we'd also have to do the same for West Penn Power. Then we could actually install our solar panel designs that will later be discussed. After that, we could actually connect our designs to the local electrical infrastructure and the grid. And then after that, we'd have to seek once again approval from Center County and West Penn Power, and then and only then could we actually begin to harness the energy from the sun for the Boalsburg Fire Company. So there are also other things that we have to consider when making the designs. The first is that since the Boalsburg Fire Company is a emergency services building, we have to make sure that emergency service vehicles would actually be able to leave the station. So that led us to select the actual roof as the ideal spot for installation of solar panels. Even though the roof is a relatively old, 6 years, it still was the ideal place for installation of solar panels, and that was confirmed with direct conversations with the client itself.
So this right here is our Aurora LiDAR, which basically just takes the surrounding and finds the high points that could, contribute to shading losses and stuff like that. So our only high points within this area would be some trees. And the one tree to the left of the old schoolhouse building has actually recently been cut down, but Helioscope hasn't updated their diagnostics, so the tree is still rendered in our designs. So this right here is our conceptual design for our design one. The figure on the left is our single line diagram that basically just shows how the solar panels are connected and how that energy harnessed from the solar panels actually makes its way to the grid. And the figure on the right is just our conceptual design, where we use the old EMS building, the one old schoolhouse, and a little portion of the roof. And in this design, we did not include using the bay roof where the trucks are stored due to concerns with our client of putting holes in that roof and the roof not being strong enough to hold the panels because they didn't want leaks to happen and just leak on the trucks and ruin them. So the figure on the left basically just shows a shading diagram of how well the solar panels are performing. And the old schoolhouse isn't performing at its maximum capacity due to that tree still being rendered in helioscope. So those, without that tree, these solar panels should actually be working much better and producing more energy than what they're showing. The total irradiance produced by this design is around 1,200 kilowatt hours per meter squared, and the total energy to the grid produced is around 35,600 kilowatt hours. Some of the losses produced by this design is mainly through shading and reflection, but the shading should be decreased since that tree was removed. And reflection, they could just get a anti-reflective coating put on the solar panel so it fully traps in the sunlight rather than it reflecting off the solar panels. This right here is our conceptual design for design 2. Again, on the left is just showing how the solar panels are connected and how the energy gets transferred to the grid. And in this design, we did end up using the bay roof after talking with our client and getting some extra info from a roofing company. We were able to convince them to allow us to put solar panels on the roof. Again, the shading on the left is the one schoolhouse because the tree's still being rendered in, and then the shading losses on the actual bay roof, I think, is just because of overlapping shadows from the slope of the roof. The total irradiance produced by this design is around 1,200 kilowatt hours per meter squared, and the total energy to the grid produced is around 94,600 kilowatt hours. The total losses from this design is mainly from reflection and shading. Again, with reflection, like I said, they could get an anti-reflective coating, and then shading, all they can really do is either cut down more trees or trim them to further increase the production.
Moving on to the selection strategy of the solar panels and inverter type we chose. We decided to use Q cells, Qtron, BLK, M, G2 panels. These are high-performance N-type solar cells showing approximately 22% efficiency. There's also no loss of area with these panels since they're completely covered in the cells. There were slight concerns with the shading from a few trees, so we wanted to use microinverters. This allows the energy production to go on a panel-by-panel basis. Therefore, if one panel is shaded, it won't affect the performance of the entire system. These solar panels have microinverters already embedded in them, making them a viable option to get maximum efficiency out of our system. This product also has a 25-year product and linear performance warranty, which helps address the concerns our client had with lifetime and degradation of the panels. They're also durable in extreme weather conditions, which is important when considering the high snow and wind loads that they could experience in the.
So when looking at our financial analysis, we first looked to see if net metering was available. Net metering is available all throughout Pennsylvania where West Penn Power supplies the power. Pennsylvania SRECs is another thing we had to look at. They're currently worth about $23.25 as of April 2026. We decided to use that value as an estimate for our 25-year lifespan, even though it is subject to change. Boalsburg is not within the energy community tax credit region or the low income region. Therefore, we can't get the 10% bonus credits that those supply. One thing we will have to do to get any bonus credits is apply for elective pay. Since the fire company is volunteer, they're a nonprofit, therefore they don't pay any taxes. We must apply for elective pay in order to receive these payments. One thing we can do is apply for a domestic content bonus credit. This is a 10% bonus credit given to projects that use a certain percentage of domestic products. The Q-Cell Qtron solar panels are made in Georgia in the United States, therefore we can apply for that. The Pennsylvania Solar Energy Program is another thing we can look at. This program offers grants and loans for solar generation projects. This is a very competitive program though, so we did not include it within our financial analysis design, but it is something to keep in mind. So our financial analysis for design 1, using the volunteer fire energy price in the Boalsburg area being at around 11 cents per kilowatt hour, the payback time for this design was just over 13 years without the 30% clean energy credit. The 30% clean energy credit can be obtained if the solar project is completed by the end of 2027. If it's completed by the end of 2027, the payback time can be reduced to about 9.4 years with that credit. This design offsets about 43% of the company's energy. It's an alright offset value, but we will prefer design 2. Design 2 generates a payback time of just over 12 years without that 30% credit. It has an 8.4 8.4-year payback time with it. Therefore, we recommend this design over the first design because of the financial viability. The offset percentage here is 114%. Therefore, we're producing more energy than the company may need. So what can we do with that excess energy? We can benefit from net metering and sell it back to the grid. At about 12,000 kilowatt hours in annual excess, this will apply about $18,000 in total benefits over the lifespan of the project. And the company is going to have to stay connected to the grid anyway, because in the months of January, February, November, December, they are using more energy than that they will produce with the solar generation. Therefore, staying connected to the grid and benefiting from net metering makes sense overall.
One of the biggest considerations for this project was what are we going to do with the roofing situation to allow for it to support the panels that we were going to put in place. Originally, when we had developed Plan 1, we did not include the bay roof, but after going to our client with some ideas of shingles that could be put in place that would allow for solar usage, they allowed us to start development on our second plan that didn't include the truck bay. Our first option is a Roser Steel Guard charcoal stone-coated steel shingle that averages about $10 to $13 per square foot. This is more of your traditional shingle that you would see on a house or on an average building. They last about 40 to 70 years, and for Plan 1, this would cost $23,000, while for Plan 2, it would be just under $55,000. The second option is the Gibraltar corrugated galvanized steel roof panels. This is the cheapest option for about $6 to $9 per square foot. These are a more industrial looking ribbed panel that lasts about 30 to 50 years. And being on the cheaper end, they would cost about $15,000 for Plan 1 and just under $36,000 for Plan 2. The most expensive but probably best option would be the modern looking cleaner tiles that are the snap lock standing seam metal panels for averaging $10 to $14 per square foot. These are going to last upwards of 50 years and cost $24,000 for Plan 1 and $57,000 for Plan 2. The community impacts of this plan would reduce grid electricity use in the area. Being the amount of energy that the fire department uses on an annual basis, it would also reduce the cost of energy and take strain away from the local grid. Our project is designed in a way that it avoids any negative operational impact on either their energy system or the energy system locally. It would also increase public welfare in that the local volunteer fire company would have stable, consistent power. And in lowering energy costs, it would make living easier for the people that reside in the town of Boalsburg Volunteer. It is also continuing to contribute to global efforts in reducing fossil fuel reliability, as this will now be the second volunteer fire department in the area that is making a large transition to a majority solar energy operational use. And we are hoping that in the future we see more companies taking the steps to switch their energy to something more reliable. Thank you very much for listening to our presentation.